Guys, please turn your cameras on, don't forget. Please, I'm gonna need everyone to have their cameras on, and please, whose usuario es Zoom? Do you mind just changing your name?
Evelyn Tapia, teacher.
Oh, all right, guys. So today we're gonna sorry. Today we're gonna continue working on the listening section. It's actually our last class for the listening section. And we're gonna be practicing TOEFL lectures, which is what we did yesterday, right? Yesterday we went through what they are, how to approach the structure. We said that every TOEFL lecture has a different structure, right? But we have some common or frequent organizational styles, right? We have things like classification, which are basically types of something. We had comparison, advantages and disadvantages, theory and evidence, causes and effect. So those were the usual organizational styles. And today we're going to practice that. Remember that the key part was being able to identify the subtopics within the lecture and taking notes accordingly, right? Dividing your paper correctly, using the right amount of space for each idea, not taking too many notes, but focusing on taking notes only for the details and trying to pay attention at least to the main ideas of each subtopic. And those were the key parts, right? So let's see, we're gonna practice that. We're gonna start with our first lecture, which is gonna be this one. It says, a university lecture on animal behavior by a professor of biology. Okay, so I'm gonna play the lecture now, and please take notes.
University lecture on
Teacher, I cannot listen to the audio.
Oh, I'm so sorry. I think I wasn't sure you listened. Okay, thanks, Ricardo. Thank you for telling me. Okay, I sorry. Sorry.
listen to part of a university lecture on animal behavior by a professor of biology. We're looking at animal behavior this week, and let's turn now, class, to one of its most dramatic manifestations, animal mimicry. Organisms that are good to eat or that are attacked for other reasons often develop devices, through evolution of course, techniques and devices to protect themselves from their attackers in order to survive and in order to reproduce and pass their genes on to the next generation. And one of these techniques, one of these strategies, is to look like something else, to look like something that is not good to eat, or something that is otherwise of no interest to the predator. An organism that does this, that resembles something else, is called a mimic, and the thing that it has evolved to resemble is called the model, while the predator that it is trying to mislead is called the recipient, the one that receives the misleading image. Some mimics do this by adopting camouflage, which is a cryptic resemblance to something of no interest to its enemy, and by doing this, they become invisible, they are hidden. Many animals, insects, lizards, amphibians, mimic the abundant plant life in the habitat around them. I'm sure that you've seen green grasshoppers and brown moths that seem to be well hidden on grass stems and tree trunks when they're motionless. But the leaf-tailed gecko, a small lizard in Madagascar, is a master at this. It avoids its enemies by looking exactly like a cluster of old dead leaves. And there are various species of katydids, grasshopper-like insects that have managed to duplicate the appearance of leaves with startling accuracy. In all stages of growth, some species looking like fresh green leaves and others looking like old decaying leaves, complete with leaf veins, weathered edges, and mildew spots. These adaptations make these animals difficult or impossible for a predator to identify or even notice, and so these otherwise defenseless creatures are overlooked or passed by. Other organisms defend themselves directly with stings or bites, or with poisons or other noxious chemicals, and such organisms often assume bold, characteristic colors and markings, called warning coloration, that warns a predator, reminds it that this creature can inflict pain or discomfort, or that it tastes very bad. The bold orange and black pattern of the common monarch butterfly, or the black and yellow bands on a bumblebee are such warning colorations. And sometimes this warning coloration is so effective that another species, a species that doesn't have any of the protective devices of sting or poison or whatever, will adopt the same warning colors and pattern. This sort of mimicry is called Batesian mimicry. The name comes from the early zoologist H.W. Bates, who back in 1862 first suggested an explanation for the origins of mimicry based on Charles Darwin's new theory of natural selection. This was one of the earliest applications of Darwin's ideas to an unknown biological phenomenon. Now, viceroy butterflies taste good to many birds, but because they mimic the monarch butterfly's model's color pattern, because viceroy butterflies look like monarch butterflies, they are avoided, just like the monarch is. In the same way, many harmless fly species resemble the bumblebee model, and also in this way they avoid being eaten by the recipients, birds. So these are Bastian mimics. There are several conditions that must be fulfilled, though, for a Bastian mimic to be successful. The mimic must of course share the same general region and habitat as its model, but the mimic must also be less numerous than its model, which must be relatively abundant. That way, the odds are that the recipient predator will sample an unpalatable model first, which is very important for keeping the trick effective. A similar kind of mimicry is Mullerian mimicry, named after another early biologist. And in this sort of mimicry, both the model and the mimic are dangerous or taste bad. A very obvious example is the way that so many unrelated species of bees, wasps, and ants have assumed similar, bold, black and yellow or black and orange banded patterns. By doing this, Mullerian mimics present a united image that predators soon learn to be weary of. There's also another aspect of mimicry that I'd like to mention too, and that's the mimicry used by predators. This is called aggressive mimicry, and it is used to conceal or misrepresent a predator until its prey comes near enough to capture. Many mantids, for example, are green or brown, so that they blend in with their plant surroundings. But some tropical mantids are fantastically shaped and colored, like the beautiful orchid mantis, which resembles a petal of one of those tropical flowers, and it hides motionless next to one of these orchids until an insect comes within its reach. There are also several green-colored vine and grass snakes of various families, which lie invisible among the tangled vines and branches of the jungle until they suddenly lash out to grab their prey. Actually, there are an endless number of ingenious mimics in the natural world, And I recommend that you all try a Google Images search tonight for some more interesting examples of this fascinating behavior.
Okay, guys, so that was the lecture. When you have biology, it tends to be a little bit more complicated, maybe mainly because of the vocabulary, right? It's a bit more technical. So in this case, they were talking about animal mimicry, right? That was the main topic. That was the behavior that was being discussed. And I'm gonna tell you, you had a classification, right? So we have how many different types of mimicry were you able to identify? One, how many?
I could identify three: Bayesian mimicry, modern mimicry, aggressive mimicry.
Okay, that's nice. So you were able to identify the last three. That's correct. You have the last three correct. Bayesian mimicry, I think it was malarial mimicry and aggressive mimicry. There was one before all of those. The first one, which one? Does anyone have it? I think it was just camouflage. You know, camouflage, then Bayesian, malarial, and aggressive. Now, when you have classification, the most common thing is to have examples for each. So it goes in the same way, always. So you have the type. So let's say Bayesian mimicry, you have the definition, so what it is, how it works, how the animals interact in that case. And then you have examples, right? So as an example, this animal, or maybe one or two animals are mentioned to illustrate that type of mimic or that type of anything, right? That's usually the structure that you have when you have classification. So you have the types, their definitions, and examples. And that's basically what we had in here, right? You should be able to identify those four ideas, those four subtopics, have your notes separately for each one of them, and be able to identify mainly what the examples were, because I guarantee that it's very common to have questions about the examples. So let's see, let's take a look at the questions. Valentina, could you please read the first
Okay, why does the lecturer mention Charles Darwin?
one? Okay, so why is that?
I think it's B.
All right, Ricardo. Yes, do you guys agree? Harry also says B. Evelyn?
I think it's with teacher.
Okay, good. Maria Rene, you there? Maria Rene also says B. And finally, Valentina?
I think also B.
Great. So B it is. I agree with you guys. So Darwin's theory was used to explain mimicry. Obviously, everything that is mentioned in the entire lecture needs to be related to mimicry, right? So I don't think it's gonna be A, for example. Although this is totally true, right? Darwin was the creator of the evolutionary theory. They're not saying whether something's true or not. They're saying why, right? And it has to be related to mimicry. And in this case, yes. His theory was used, I think, by one zoologist to first explain what mimicry was. Now, second question. Ricardo, could you please read it?
What is the term used for an organism that is fooled by mimicry?
Okay, great. So,
I think it's A.
recipient, yes. Okay, what about the rest? So Evelyn says A, 2. Henry? Maria Rene? Okay, so Maria Rene says D, the prey. Okay. So let's see, we're gonna go for A because majority means, let's see. And I do think it's A. There were only 3 terms mentioned. I think it was the mimic, the model, and the recipient, right? So let's just use our logic. The one that is full, even by looking at the grammar part, this is the passive voice, right? So the object is receiving the action, the one that is full. One that is full is receiving the mimicry. The one that's doing the mimicry is the mimic, right? The one that's doing it. The one that receives it is the recipient. And well, the mimic is trying to imitate or resemble the model, right? Which could be another animal or part of the environment. Device and prey, I don't think there were options. But let's see. Now, question 3 says, why does the lecture mention katydids? Why were these animals mentioned? Probably as an example, right? But as an example of what? Do you have katydids in your notes? Can you tell me where it is located? Is it an example for camouflage? Is it an example for Bayesian mimicry, for Mullerian mimicry, or aggressive mimicry? Because that would answer the question. So Ricardo says B or D, okay? But you gotta choose one, so B or D. Evelyn says B because they resemble bumblebees, okay? I think bumblebees are mentioned for Mullerian mimicry, right? So katydids and bumblebees. Henry says D because they look like leaves, okay? So because they taste that, the way that the animal tastes, or whether they're poisonous or not, that is related to what type of mimicry? Does anyone remember? Because they taste bad. What type of mimicry is that?
I think it's the one that came before Bayesian mimicry.
4, so camouflage.
I think.
Okay, I don't know. So hang on. So for example, here we have it, right? Bayesian. So for example, these butterflies taste good to many birds, but they mimic another butterfly that doesn't taste good, right? That is an example of Bayesian mimicry. So animals that resemble other animals that taste bad. Resemble bumblebees, I think the flies were the one some flies or some species of flies resembled bumblebees, right? Because bumblebees can sting and they want to appear dangerous to their prey. And I think that was Mullerian mimicry. C is also Mullerian mimicry, but I think I'm going to go with Henry on this one, and it'll be D because they look like leaves. So this was an example of camouflage. It was mentioned in the beginning. Katydids are an example of camouflage. See, some mimics do this by adopting camouflage. And then they give the example of, let's see, and there are various species of katydids, grasshopper-like insects, that have managed to duplicate the appearance of leaves, right? So that's an example of camouflage. Now, if you know what katydids are, you can picture them, then that makes things easier because you would know that they don't resemble bumblebees, that they don't stink, right? Do you guys know what katydids are? Or grasshoppers? They are in Spanish, saltamontes. So you know that they don't sting and they don't resemble bumblebees, right? But they don't look like leaves. Okay. Now question 4. It says some moths and butterflies have large O-like eye spots concealed on their underwings, which they can suddenly display to a predator. Which kind of mimicry is this an example of? What do you guys think? What would you say? So moths and butterflies are mentioned as an example of, Henry says aggressive mimicry. Ricardo says aggressive mimicry too. Evelyn says aggressive mimicry. Okay, I think we all agree. Environment. Okay, okay, guys. Does it make sense though? What was aggressive mimicry? Do you guys remember what it was? Was it done? I think aggressive mimicry was the only one that wasn't done by the prey to escape the predator. What was aggressive mimicry? Ricardo, do you remember what it was?
I wrote when it gets to misrepresent predator.
Misrepresented.
Something like that.
I think they look like the predator's eyes. Oh, like eyes. Okay. Okay. Okay, guys. So let's choose the honesty. I think the way that I remember this was that aggressive mimicry was used by predators to catch their prey because aggressive mimicry was the last one, right? So if I'm not mistaken, aggressive mimicry, I think you had the examples of some snakes that wanted to catch their prey and they looked like something else and they stayed there motionless without moving anything until the prey came and then they caught it, right? That was aggressive mimicry the way that I remember, done by the predator in order to catch the prey. So they can suddenly display to a predator? I don't think so because they're not the prey, the way that I remember. But let's see. Okay, let's see. Now question 5 says, which organism is presented as an example of malaria mimicry? Okay, here it says malaria mimicry. I'm guessing that it's gonna be for the previous one, right? So option C, we're gonna keep that in mind. Okay. What about this one? Question 5. So, what's an example of malaria mimicry? Harry says A, the visible butterfly. Okay, but we just read the transcript, right? Was it really A or C, the monarch butterfly? You guys are talking about butterflies. You sure? Evelyn says C, the monarch butterfly. Are you guys totally sure? I don't think so. Remember we were reading the transcript? The butterflies were used to I think, to give an example for Bayesian mimicry, right? Camouflage was the one about the katydids, the lizards, the grasshoppers. The second one, Bayesian mimicry, was the one that talked about butterflies, I think. And then Mullerian mimicry was another one. I don't know. Let's go for C, which is the most voted one, and we'll see the answer later. Now, finally, this is interesting. Which would be the best title for this lecture? What do you guys think? Think about it, right? Animal behavior was already the title. So, I don't know. Animal creativity. Is it something related to how creative the animals are? Animal deception. Do they actually do this? Deception means to fool something, to fool somebody. Or escapades. I don't know. What do you think? Ricardo says C, okay. Mary agrees. Okay. So yeah, I think it is C. Because it's all about how escapades could be another one, but not all of the animals that were mentioned were trying to escape. Some of them were actually trying to catch their prey. Right? So deception, yes. Let's see, let's check. So first one's correct. It was used to explain mimicry. Second one is correct as well. The organism that is fooled by mimicry is the recipient, the one that receives the action. The lecturer mentions katydids because they look like leaves, right? It's an example of camouflage. Now here, the moths and butterflies were mentioned as an example of Bayesian mimicry, right? As I told you, and as I remember, aggressive mimicry is the one done by the predator to catch the prey. And they mention other examples there. The one that I remember are snakes. But I think there was one more. Okay, so they cannot display to a predator if they are the predator. So it has to be Bayesian, or I think it's Bayesian, right? Bayesian mimicry. Now, the organism presented as an example of Mullerian mimicry was actually the mantis, the orchid mantis. Okay, the butterflies were examples of Bayesian mimicry. And the leaf-tailed gecko was an example of camouflage. So it has to be the orchid mantis. Another thing, just to like, some of you guys were choosing A and C, right? Those were your choices. Now, if you think about it, if you remember, both of them were together. The visceral butterfly imitated the monarch butterfly. So if this was actually correct, and the butterflies were used as an example of Mullerian mimicry, then both of them could be correct. So how do you know that it's A and not C, or C and not A, right? Because both of them are mentioned as an examples of Bayesian mimicry. So just by looking at this and knowing that you have two of the same example, then it couldn't be either of them, right? It has to be one of these two. And the leaf-tailed gecko was mentioned as an example of camouflage, so it's gotta be B. Okay, guys? Just by looking at it. And great, animal deception would be a good title. What do you guys think? We got 4 out of 6. How do you feel? Do you have any questions so far? No questions? Okay, so please get ready. We're gonna do another one. I'm gonna play the lecture in a bit.
Listen to part of a lecture from a life sciences class. Raise your hand if you're right-handed. Yup, that looks typical. Most of us, about 90%, are right-handed. It's been that way throughout history. In nearly every culture, right has been associated with positive qualities, while the left has been associated with negative, or even evil ones. In Latin, left means sinister. In ancient Japan, men could reject or refuse to marry women who were left-handed. In modern China, teachers try to force left-handed students to learn to write with their right hands. And, as I'm sure all lefties know, everyday items like can openers, scissors, computer keyboards are designed for righties. In short, left-handers have been made to feel left out. Get it? It might seem straightforward to you and I, but scientifically speaking, the basis of handedness is not well understood. Most scientists define right-handed or left-handed on the basis of a person's preferred writing hand. But some scientists claim it should be based on the hand that is faster and more accurate in performing manual activities like tightening a screw or tying a knot. Still others claim that ability doesn't matter. In other words, that handedness should denote only preference. Yes, question.
What about people who are who use both hands?
You mean ambidextrous. Actually, most scientists agree that genuine ambidexterity is rare, and several of them believe it even rates its own special category as a distinct type of handedness. The reason for this is that most people can perform several functions relatively equal with either hand, which causes another scientific fraction to argue that there are actually only two types of handedness, right and non-right. This group advocates measuring handedness on a continuum, from 100% right-handed to 100% left-handed. On this scale, we'd say something like, I'm 60% right-handed, or I'm 82.5% right-handed. Though how we'd determine who's more right-handed than another would open up a whole new can of worms. Okay, yes.
How do people become right-handed or left-handed in the first place? Does it come from your genes?
Mostly, yes. Research shows that handedness is largely genetic. Interestingly, though, even when both parents are left-handed, the odds are no better than 50-50 that their children will be lefties. Some scientists believe there is a specific gene that determines right-handedness, but the trouble is that they can't pinpoint it. They think this gene also aids in development of speech and language comprehension. Many researchers believe that handedness is a result of something called brain lateralization, which is the concept that each hemisphere of the brain controls different bodily functions. Researchers have long been believed that a person's dominant hand is on the opposite side of the brain hemisphere that controls their language specialization, so that right-handed people use the left half of their brain for processing language. But brain lateralization is not well documented, and there is evidence that seems to contradict this concept. For instance, while it's true that more than 90% of right-handed people do process language in their left hemisphere, recent research shows that about 40% of left-handed people also process language primarily in the left side of their brain. Additionally, only 10% of lefties rely primarily on their right brain to process language. So, what can we make of this? Though genetics clearly play a vital role in determining handedness, environment also seems to be an important factor. A recent archaeological study compared a group of modern Canadians with 1,000-year-old skeletons from a British farming community. The Canadians showed right-handed dominance by a 9-to-1 ratio of larger right elbows than left ones. In the ancient skeletons, however, most right and left elbows were equal. Now, this doesn't prove that the British farmers were ambidextrous, but researchers say it does suggest that handedness can be subject to societal influence. So for many, the best hypothesis at this time is that handedness results from a complex interaction of nature and nurture.
Okay, guys. So that was the second lecture. Now, in this case, they talked about handedness, right? That was the topic. But what specifically do they say about handedness? What type of information do we get? What were the subtopics that you were able to identify? What would you guys say?
Where it comes from.
Okay, that was a big thing, right? Where it comes from. Is it genetics? Is it biological? Is it from our environment? And they discussed all of that, right? There's genetics theories. I think there are many theories, right? And they discussed what theories are the most plausible ones and what the problems with those theories are. What else? Anything else you guys remember? In the first part, they talked about the prejudices as well, right? They talked about like how right-handed or left-handed people are seen in different cultures, and kind of how left-handed, left-handed people are left out, right? That was some sort of a joke that he did. So let's see, let's look at our questions. The first one we have is, what is the main topic of the lecture? What would you guys say? What was this main topic?
I think is um, thing is the
Scientific basis of handedness? Yes. Okay, Henry agrees. Do you guys agree too? Evelyn? Okay, great. Valentina? Maria Rene?
D.
Okay, Valentina says B, right-handed dominance. Or you said D?
D.
D as in both?
No, D.
Oh.
The last one.
Okay, great. So yes, I think we all agree that scientific basis of handedness. They do talk about everything else that is in options A, B, and C. You know, they talked about the definition of handedness, right-handed dominance, and handedness genetics. But overall, it was all related to the science behind handedness, right? Please guys, give me a second. Okay, thanks, sorry. So yes, the scientific basis of handedness, that encompasses everything, right? All of the other ones are too specific. Now, question number 2 says, why does the professor mention Japan and China? What would you guys say? Okay, Ricardo says C, Maria Rene says C. Henry says C. Evelyn, Valentina, what would you guys think?
C.
The option C.
Great, so yes, they are examples of handedness prejudices. So they do talk about how handedness is seen in different countries, and Japan and China were 2 examples. Nice. Now, question 3 says, according to the professor, what is the problem with the concept of brain lateralization? Henry says C, or Ricardo says C, I think Henry says B. C, B, okay. Maria Rene says B. Henry says C. Okay, Evelyn says C. Okay, guys, let's go for C, although I'm not completely sure. As far as B goes, the same part of the brain controls all bodily functions seems too extreme for me. All bodily functions? I don't know about that. I think that they actually distinguish, right, what the right and the left side of the brain controls, and they were different functions. Now, as for C, I'm not sure either because it says it has been disproven by a recent archaeological study, right? So I think that the archaeological study was mentioned later when they were talking about how the environment influences handedness, but not when they were talking about the biological part, right? How our biology influences. I don't know. I'm sorry. Okay, let's see. We're gonna see when we get to the answers. Question 4 says, why does the professor say this? Get it? And we're gonna hear that part again. It's around here.
Items like can openers, scissors, computer keyboards are designed for righties. In short, left-handers have been made to feel left out. Get it? Scissors, computer keyboards are designed for righties. In short, left-handers have been made to feel left out. Get it?
Why does the professor say get it? Okay, Henry says D. He wants to see if the students are paying attention. Okay. Maria says B. He wants to direct students' attention to a pen. Ricardo also says B. What about the rest? Evelyn?
The option D, teacher.
Wants to see, okay. We have 2, and Valentina, you're gonna break the time.
B.
B. Okay. Do you guys know what this is? Those of you who chose B, what's a pen? We're gonna look for the definition. It's basically like a game of words, right? It's like a way to organize your words. It says a joke exploiting the different possible meanings of a word, or the fact that there are words which sound alike but have different meanings. For example, the pigs were a sequel, or a squeal. The pigs were a squeal, right? That's an example. And we have the verb make a joke explaining the same thing, right? So what do you guys think now? What does the professor say before? Okay, before saying get it? He says, in short, lefties have been made feel as if they are left out, right? Something like that. Like lefties feel left out. So that is a pun, right? Because the professor is playing with the word left and using it, well, it's using the same word but in different contexts, right? With different meanings. So he's exploiting the fact that the word left has 2 different meanings. So left, as in right and left, and left out, right? As they are excluded. So leftists have been made feel like they are left out. That's a part. And he says get it because he wants to see if the students got the joke, right, or not. He wants to direct students' attention to that joke he did. Is that okay? Question 5 then. Ricardo, could you please read the question?
In the lecture, the professor mentions problems scientists have in determining handedness. Indicate which of the following statements is true.
Okay, guys. So what do you think is true? Obviously, which of the following statements is true about the problems that scientists have in determining handedness, right? That's another way to phrase this question. It's a little bit oddly phrased. But basically, they're saying which of the following statements is true related to the problems that scientists have in determining handedness, because it's something that wasn't determined yet, right? We don't know what determines handedness. So what is a problem? Okay, we have a message. Ricardo says, I think it's D. About 90% of left-handers process language in the left side of their left brain. Okay. Henry says D. Only 2% of all people are genuinely ambidextrous. Okay. Where are the rest? What was the rest name? Here we have one more. Evelyn says D. About 90% of left-handers. Valentina, what about you?
It could be D.
D, okay. And Maria Luna? Maria Luna says D. Okay, we're gonna go with D, but I don't know. Would that really be a problem? I think that the math is incorrect because if you think about it, would that actually be a problem? Wouldn't that maybe be a solution for the problem of determining handedness? Because if 90% of left-handers really process language in their left side of their left brain, then there you have the connection, right? That would be what determines handedness, where you process language. If it's in your left side of your left brain, then you're left-handed. Well, not all of the time, right? But 90% of the time, you're very likely to be left-handed. But if you don't, maybe if you process language in your right side of the brain, then you're more likely to be right-handed. So that is what would determine handedness, right? And that would actually solve the question of what determines handedness. So I think there's something wrong about that fact. It's probably going to be that number, right? I don't think it's about 90%. It should be way less than that, like 50%. So in that case, it'd be something impossible to answer, right? That couldn't be the answer where you process language, whether it's in your left or right side of your brain. So I don't really see it as being a problem. Now, option C, only 2% of people are genuinely ambidextrous. Same thing here, right? So what would the problem be? I don't see it. I don't really see it, you know, that doesn't really sound like a problem. Options A and B could be, but like if we look at option B, it says most scientists define handedness by manual performance accuracy. So if most scientists agree with something, again, why would that be a problem, right? That doesn't sound like a problem. But option A sounds like a problem, right? So some scientists claim the only handedness is right and not right. And maybe other scientists disagree. That could be a problem. I don't know. We're gonna see. Let's check our answers. Okay. The first one, great. The main topic of the lecture was indeed the scientific basis of handedness, because he was trying to explain what determines handedness. Now, question number 2, why does the professor mention Japan and China? Great. They were used as examples of handedness prejudices. So yes, they are mentioned in the beginning, and they are examples of how different cultures see handedness in different ways, right? And usually there's a prejudice against left-handers. Now, question 3, according to the professor, what's the problem with the concept of brain lateralization? So it was actually D. And this is very similar to the last question, right? I told you, C makes sense in the fact that it could be a problem. So this theory is not accepted because of a problem. Now the problem could be C or D. Both of them could be problems. But option C is talking about a recent archaeological study. And we know that, first of all, archaeology doesn't study that. You know, it has nothing to do with biology. Well, yes, something to do, right? But I think the archaeological study was mentioned later to explain to what extent our environment defines whether we are left-handers or right-handers. But instead, C was the problem, right? It does not seem to apply to determining handedness. And I think that's related to the last question. This is related to brain lateralization, right? So if 90% of left-handers really process language on their left side, then that wouldn't be a problem. That would be in favor of this concept of brain lateralization, right? That would be the correct theory, that would be most accepted one. But it's not, because it's not like that. That's not the percentage of people that, or of left-handed people that process language in their left side of the brain. Okay? Is that okay so far? Do you have any questions? Do you guys understand that part? Why some of the options cannot really be problems? That's important too, you know, especially if you're not 100% sure about the answer. It's important to analyze the options, because some of them are always going to be out of context. They won't make sense. They will go off topic. So it's important to eliminate those options. Now, question 4 says, why does the professor say this? Get it. And yes, he was right. He wants to emphasize that or reinforce that joke he did. And finally, question 5. In the lecture, the professor mentions problems scientists have in determining handedness. Which of them is true? It was A. Some scientists claim the only handedness is right and not right. These are not problems, right? And they have incorrect information. If we look at the transcript, I don't know if you can do that. We look at the transcript, and maybe we'll see what mistakes we made. Check. Okay. So here we have many researchers believe handedness is a result of brain lateralization, which is, okay. So for instance, while it's true that more than 90% of right-handed people do process language in their left hemisphere, so it was 90% of right-handed people process language in their left hemisphere, Recent research shows that about 40% of left-handed people also process language primarily in the left side, right? So that was the correct number. 40% of left-handed people process language in their left side. So 60 of them process language in their right side. So as you can see, it's not really an indicator. So that was what we had. Is that okay? Do you guys have any questions about this lecture we did? No questions there? Is it all clear? Okay, guys. So I recommend, again, you need to practice. I've seen it in many students. Reading and listening is all about practice, but you need to actively practice, right? The way we said yesterday. You need to see what is it that is making you have wrong answers. Is it your notes? Is it the details? Is it the speed? Is it that you get distracted? Is it that you're not paying enough attention to the main ideas? Is it that you're not able to identify the way that the professor speaks and know which information is more important than the other? So you need to understand what your problem is, and based on that, you need to work on that, right? Depending on what it is, you'll use different strategies. That's practice. If you do one lecture a day, analyzing your responses and analyzing how you're doing, and you'll be really good at this. You guys? Do you guys have any questions there before we go? No? So if not, please don't forget today's daily survey. I just launched it. And I'll be seeing you guys on Tuesday. All right, next week. We're going to start with the speaking section next week. So I hope to see you guys there. Have a great weekend. See you next class.
Thank you, teacher.
Bye,
You too.
teacher.
Thank you, teacher.
Guys.
Thank you, teacher.